Now I'm going to teach you about different methods of subtracting decimals. Subtraction of decimals. The question is, what is 7.2 take away 5.7? There are three methods I'm going to show you here. There's the counting on method, there's the formal algorithm, or there's the jumping backwards method. Firstly, it is very important to realise that 7.2 take away 5.7 is exactly the same as asking what is 5.7 add on which amount will get you to 7.2. So 7.2 take away 5.7 is the same as 5.7 add on what equals 7.2. Just like 10 take away 2 you know is 8 is the same as asking 2 add on what will get you to 10. And that's what this counting on method is based on. So in order to do this, I start with the smaller number, which is 5.7, and I put it at the beginning of my number line. And what I'm wanting to know is, how much do I have to add on to 5.7 in order to get to 7.2? So I'm going to put 7.2 towards the end of my number line. And now I'm going to make jumps of any size in order to get from 5.7 to 7.2. What do you think the best jumps should be? Well, I always say to myself, let me try and get from 5.7 to the next whole number. The next whole number would be 6. So what would my jump need to be to get from 5.7 to 6, which is 6.0? I would have to add on 3/10 or 0.3, and that is what I'm going to do first. So I'm going to make a jump, jump to 6, the whole number 6, but what's important is I write at the top I've added on 0.3. Now I've got to jump between 6 to get to 7.2, and that I find I can actually do in one jump. I'm going to go straight from 6 to 7.2. Well, some of you might want to just go to 7 first. Will we do it in 2 jumps? If I did it in 2 jumps, I could jump to 7, and there I've added one whole. Now be careful, one whole doesn't have a decimal. The decimal point would be after it if I wanted to write it as a decimal. I can do that, I suppose. So here I've jumped from 5.7 to 6 was adding on 0.3. From 6 to 7 is adding the whole number 1. And then from 7 to 7.2, what would I add? Yes, I would add 0.2. Now, that's all great that you've done that, but you need to understand what the answer is. So the question was, how many did I have to add on to 5.7 to get to 7.2? These are what I had to add on, the 0.3, the 1 and the 0.2. So what I have to do is I have to add those 3 numbers together, and the end value I get, well, I've got 1 in the ones place, decimal point, and I have 2/10, add on 3/10, which is 5/10. And there's my answer, 1.5. So 7.2 take away 5.7 is 1.5. Okay, now if I do it the formal algorithm, and this is the formal algorithm. Now, that just means you're calculating in columns, just like your normal whole numbers you've learnt to do. But remember, here's the decimal point. The place after the decimal point is tenths. That stands for tenths. And the place before the decimal point is your ones house. So I have to align, that means line them up, the digits in the correct houses. So 7.2 looks like this, 5.7 looks like this, the decimal points are on top of each other, my takeaway sign is here, so I just take away as normal. Well, 2/10 take away 7/10. Oh no, I don't have enough to take away 7. But this value belongs to each other, 7.2. So I go to the ones and I say, please, please help me. Can I exchange one of your ones to 10/10? Because we all remember that 10/10 is the same as a whole number, or the number 1. So that's what we do. We take one of the ones, 1/2, which leaves you with 6. So I'll score that out and write 6. And with that 1/2, it becomes 10/10, because 1/2 is the same as 10/10. So now I have 12/10. Well, that helps me greatly. If I've got 12/10, I can do 12/10 take away 7/10. 12 take away 7 is 5. And then I go to the ones house, and 6 take away 5 is the whole number 1, which I will write in. So there we have it again. 7.2 take away 5.7 is 1.5. Now the last method here is jumping backwards. In this case, we take the large number, the one that's been on top here, 7.2, and I'm going to put it at the end of my line here. Oh, 7.2. And now I've got to take away 5.7. Right, I'm going to do it in jumps again, but it's up to you how many you want to take away at a time. But I'm going to start straight away by taking my 5. So I've taken away the 5 part of 5.7. So this I will have taken away already. So 7.2 take away 5 whole numbers, 5 ones, will get me down to 2.2, which I write here. All right, now where do I go next? Well, I've taken away 5, but I've still got the 0.7, which is 0.7. So, and I have to take the 0.7 away from the 2.2. Oh no, that's quite difficult to do in my head. So I think I'll take the 0.2 away first. Oh, I need to change here. And 2.2, take away 0.2 will get me to the whole number 2. But have I taken away 5.7? No, not yet. I've taken away 5.2. So I've still got another 0.5 to take away. So I'm going to take the 0.5 away. 2 take away 0.5 is 1.5. Now what can be quite confusing here is, well, what's my answer? So here I started at 7.2, I took away my 5.7, so this is where I find my answer. What answer did I end up with? I ended up with 1.5. So there are my 3 different methods of doing the same calculation. This is called the counting on method, and this method I actually like. Mentally, I would do it this way. If somebody asked me what's 7.2, take away 5.7, in my head I'd be starting at 5.7 and counting up until I got to the 7.2. And there you just have to remember to put together the parts you added up, the jumps you added, which is 1.5. This is a formal algorithm, which lots of children like because it's a mechanical method that people learn and don't have to think too much about. But it's very important here that you realise the reason this works is because your 1 whole is the same as 10/10. So 6 wholes or 6 ones and 12/10 is the same as 7 wholes and 2/10. You have to realise they're the same. That's why this is allowed to be done. And you get your 1.5. This way is perhaps the most tricky, I think, in your mind to do. But if it makes sense to you and you like it this way, then you choose the method that suits you best and suits the numbers best in the calculation. Thank you for watching. Bye-bye.